All right, so we are going to start today specifically talking about acids and how do we write them and how do we name them. What are acids? Acids are a particular type of ionic compound. Okay, so these are not covalent compounds. So what you know here is that it is going to be between a nonmetal and a metal usually. Okay, so the thing that makes it an acid is they have to have a bunch of hydrogen, some hydrogen, and they give off hydrogen ions in water. And so they are typically going to consist of an anion, which remember is a negative ion, and a nonmetal or a polyatomic ion. And this just means an ion, which is something with a charge. Okay. This is anything with a charge is an ion. And polyatomic means it's going to have a couple of different elements in it or a couple of different atoms in it instead of just being like carbon. So in general, when we're writing a chemical formula, the chemical formula for acid is going to always, because they consist of hydrogen, are always going to have a hydrogen in it. And N is going to be how many hydrogens there are. So hydrogen and then how many hydrogens there are. And N is going to be determined by the number, by the charge on the anion, and we'll see that in just a second. So the charge is determined by looking at the periodic table. This we did already. This was when we looked at the periodic table and then we said all the atoms in this first group are going to be +1, then +2, +3, plus or -4, -3, -2, -1. Remember that? That's why we did it, so that we could determine the charge of the anion. Now, these are typical polyatomic ions. These are ones with a charge of -1, -2, -3. These are the ones that are going to make our acids. So when you see a chemical formula and you need to write it out, this is going to help you write it. If you need to know what the charge is, so you know how many hydrogens to put in your formula, then you have this chart here. So I'm going to give you this chart. You're going to have this chart to use. And so it'll be really easy for you to name the acid. All right, so let's try it. Naming acids. Naming binary acids. So a binary acid is a hydrogen plus a monoatomic, so one element, anion, which means a negative charge. So it is a hydrogen plus one element, so not more than one other letter, not more than one other element that has a negative charge. It's going to be further on the right-hand side of your periodic table. The anion has the prefix hydro and the suffix IC, and then you add the word acid. So it sounds complicated, but I promise it's not. All right, hydrogen plus the nonmetal begin with hydro, okay, for whatever the nonmetal is. So if we have the nonmetal of nitrogen, right? Then we begin with hydronitric, because we're going to take the last part of nitrogen, we'll take that off, add ic, acid, hydronitric acid. All right? So here we go. Here's a H. All right? This is binary acid. So this is your monoatomic, okay, ion. We know chlorine is a -1 because we looked that up on the periodic chart. So here, and so we know that the one's going to be right here. Hydrochloric, all right? So we took the basic acid, hydrochloric acid. Now, it wouldn't sound right if I said hydrochlorinic acid. So use your best judgment when you're trying to add that ic on the end, all right? This one is hydrosulfuric acid. Hydrosulfuric acid. All right? Now, it's a little bit more complicated when we're naming tertiary ions, which is basically a hydrogen again, plus a polyatomic anion. So that goes back to this chart here, right here, polyatomic ions. So you're going to need to have that chart handy when you're doing this. So polyatomic ions can do this. polyatomic ions ending in ITE or polyatomic ions ending in 8. Now, how are you going to know? Sorry to keep going back and forth. You're going to go here. This is going to show you 8, 8, 8, 8. All right? Use the chart that you have. So, if it ends in "ite," you replace "ite" with "ose" and add acid. If it replaced in "ace," you replace it with "ic" and add an acid. So again, use your chart. So HNO2. So this is the hydrogen, and then this is your polyatomic ion. All right, NO2. So if I go back to my chart over here, sorry to keep doing the flipping. NO2 is right here. It's an ite. So what was my rule? What was my rule with my ite? If it's an ite ending, I'm going to replace ite with os and add the word acid. So change the ite to os, nitrous, and then add acid, nitrous acid. Here we have the polyatomic ion, which is at -2, and it has the ITE ending. So change the ITE to OUS, sulfurous acid. Sulfurous acid. Again, NO3, -1 is the nitrate. So change the 8 to an ic, nitric, and then add acid, nitric acid. H2SO4. SO4 is the -2, the anion, is the sulfate polyatomic ion. Again, from the chart. Change the 8 to ic, and then add acid. So this is sulfuric acid. This is sulfurous acid. So how you change, whether you change it to an ic or an os, makes a big difference, because that is telling us about that particular ion. The way I remember which polyatomic ion gets the os and which gets the 8, os has us as a part of it, and I am a part of us. So I changes to os, 8 changes to ic because I ate something that tasted ick. So this is how I'm trying to remember what goes with what. All right. So here is our practice. Go ahead and pause the video and do some practicing. All right, so rather than go through every single one, I'm just going to pick a couple to go to. First of all, C2O4 was not on your polyatomic ion sheet for reasons I don't know. It is called oxalate. So because it's ATE, it's oxalic acid. All right, these are easy. Hydro plus the root word, add IC and acid. Hydrobromic acid. So hydroiodonic acid. Okay, so that's how you do it when there's just one. These polyatomic ions I got from the chart. Now, one I want to call your attention to is this one. ClO4. If I go back to my chart here and I see ClO4, it's called perchlorate. So it's an ATE ending, but it's not just chlorate, it's perchlorate. So that's going to be part of my name. Okay, perchlorate. So this is perchloric acid. Okay, because it has an ATE ending, I put the ic on the end, then acid. All right, so double check yourself, make sure that you got these right and you understand how to do that. All right, so now how do we write a formula? The first step is to identify if the acid is binary or tertiary. So when looking at the name of the acid, you can tell the difference. Binary begins with hydro, tertiary, the name doesn't begin with hydro. Any polyatomic ion that ends in IDE, so example, I'm looking at there's not very many. If I'm looking at the hydroxide is one, cyanide is one. So I'll just write this hydroxide, cyanide, And that's pretty much all that's on your polyatomic ion sheet. They're going to sound like a binary even though that they're a polyatomic ion. So just keep an eye out for those. Hydroxide is OH and cyanide is CN. All right. All right, so when you write the formula for an acid, you make sure the overall charge of the compound is 0. So you have to balance the charges by adding subscripts if it's necessary. So that's why the polyatomic ion chart that I gave you is so important, because it shows you what has a -1, what has a -2, what has a -3, etc. So for acids, the charge of the anion will become the subscript for the hydrogen in the formula. So for a nonmetal anion, the group number on the periodic chart will tell you. Okay, so again, to reiterate, for acids, the charge of the anion is going to be the subscript. So the charge is the subscript. Charge is the subscript. So for a nonmetal anion, okay, so this is just when we have one atom, you're going to get that charge off the periodic chart like we've talked about several million times already. For a polyatomic ion, it's going to be on the polyatomic ion sheet that's in your notes, that's on the slide that I keep referring to over and over and over again. The subscripts don't have a positive or negative sign to them. All right. Hydrosulfuric acid. It begins with hydro, so we know it's binary. The element is sulfur. We can see that right there. Sulfur is in group 16, so it has a -2 charge. So this becomes the subscript for the hydrogen. So we have hydrogen H with the subscript of 2, which we know because sulfur has a negative charge, a -2 charge. We know that from the periodic table. So H2s. Hydrofluoric acid. We know it's binary again because it has hydro in the front. The element is fluorine. It's in group 17, so it has a -1 charge. So we won't write the 1 right here. If you don't write anything, it's assumed to be 1. All right, so acidic acid, no hydro, so we know it's tertiary. It ends in ic, so we need to look for an 8. We need to look for some 8. So the acetate ion, if you look on your sheet, is C2H3O2. This is where so you're working backwards. So you see that it's acidic. So you take off the ic and you know you put the 8 back in there. We're just doing the opposite of what we did before. Now it's acetate. So then you go to your polyatomic ion chart, you look up acetate, and you know that it is C2H3O2. This whole thing you get straight from the polyatomic ion chart. It also tells you that it's a -1, which means you just add 1 hydrogen onto the end. All right, chlorous acid. No hydro, so we know it's tertiary. It ends in OUS, so we're going to exchange the OUS for the ite. So we're looking for chlorite. So we go to our chart, we look for chlorite, that's ClO2, and we know that it's a -1 ion, so we just need to add 1 hydrogen. All right, so now it is your time to do these items. So we know that this has an IC ending, so what we are looking for on our polyatomic ion chart is something with an ATE ending, chlorate. So I look, and chlorate is ClO3, and we know it's a -1, so we just put an H in the front. Nitrous, we know that nitrous will be ITE because it's OUS, ITE. So we're looking for nitrite on our chart, and nitrite on our chart is NO2, and we know it has a -1, so we have an H over here. So this is nitric acid. We know because it's an IC that we are looking for an 8 ending. We look on our chart. Nitrate is NO3, and we see that it has a -1 charge. So all we need is 1 hydrogen out in front. Phosphoric acid, we know that ic goes with 8. So we're looking on our polyatomic ion chart for phosphate. And if we look up here to phosphate, we find PO4, And that has a -3, says our chart, so we know we need 3 hydrogens. All right, hydrobromic acid. We know that it is going to be a monoatomic because we have hydro, the same one with the next one. So these are just going to be the bromide or the iodine. So we look up on our periodic table the bromine and the iodine, and we have these letters right here. And then we're just going to look up on our ion chart. So bromine, bromine is Br. Bromine is a -1. So remember the ion amount becomes the subscript, which we don't write 1. Then we have iodine is also -1, so this just has 1 hydrogen in front of it. Then sulfurous acid, we know because it's OUS that we're looking on our polyatomic ion chart for an ITE. For an ITE. So we're looking at sulfite, which is SO3, and it is a -2 charge, which means we have a subscript of 2.